Hello everyone, myself Sneha and I am from Sri Venkateshwara College of Engineering. Today we are going to see about automata theory and compiler design. So in this, let's discuss about minimization of DFA. The DFA minimization is a process of transforming a given deterministic finite automata to its equivalent DFA with a minimum number of states. The DFA minimization is also called as optimization of DFA and uses partitioning algorithm. So there are steps to minimize the DFA. Suppose there is two steps P and Q of DFA are equivalent if and only if P, W and Q, W are leading to the final states. To find the equivalence of DFA, we can use the table filling algorithm. There are 5 steps to minimize the DFA. Step 1 is remove all non-reachable states. And step 2 is for each pair P, Q, where P belongs to Q and Q belongs to Q. If P belongs to F and Q does not belongs to F, or P does not belongs to F and Q belongs to F, then mark the pair P, Q as X in the table. Step 3 is for each pair P, Q and for each symbol A belongs to alphabet, find row of P, A equals R and row of Q, A equals S. If the pair R, S is not in the table, then mark the pair P, Q. Step 4 is repeat the step 3 until no more markings can be made. Step 5 is combine the unmarked states. Let's see for example for the minimization of DFA. Here this is a question for which there are 5 states Q0, Q1, Q2, Q3 and Q4. Here Q0 is the starting state and Q4 is the final state. So Q0 on giving A it moves to the Q1, on B it moves to the Q2. Q1 on A it is a self loop, it remains in the Q1 itself. On B it moves to the Q3. Q2 on A it moves to the Q1, on B it's a self loop, it remains in the Q2 itself, and Q3 on giving A it moves to the Q1, on B it moves to the Q4. So Q4 on giving A it moves to the Q1 and on B it moves to the Q2. So let's solve this. So let's find out the solution for the given problem. Here's a question in which we have to find out the minimization of DFA. So according to the 5 steps, we'll solve the given problem. Step 1 is we have to check whether all the states are reachable. If there's a presence of non-reachable state, we'll remove the non-reachable state from the DFA. So here from Q0 we can able to move for the Q1 and we can able to move for the Q3 state also, and for the Q2 we can directly reach from the Q0 itself, and for the Q4 we can reach by coming Q3 to Q4. So here we can able to move for the all the states, and for this for the step 1 there are no non-reachable states, and we can move for the further steps. And step 2 is we'll mark the table. So we will consider the two states in which one state is final state and one more state is a non-final state. If the condition is one state is final and one more state is non-final, we'll mark X in the table, or else we'll leave it as it is and we'll be solving further. So here let's consider Q0 and Q1. Here Q0 is a non-final state and Q1 is also non-final state, so we'll not mark initially in the table. In the same way, Q2 and Q0 are also both non-final state, will not be not marking in the table. And Q0, Q3 also is the same condition in which both the non-final states will be not marking in the table. If we consider Q4 and Q0, Q0 is a non-final state and Q4 is a final state. So we'll mark X in the table. In the same way, we'll mark remaining, we'll check all the states and we'll mark in the table by checking the condition one state is final state and one more state is a non-final state. So if we move forward here in the step 3, we'll be solving for the unmarked states in the table. So we'll consider Q0 and Q1 which is not marked in the table. So Q0 and Q1 on giving A, it both states enter into the Q1 itself, and on B it enters into Q2, Q3. So we'll be checking either any of the state is marked in the table or not. if any of the either state is marked in the table, we'll be also marking Q0 and Q1, or else we'll be not marking. So here both Q1 and Q2, Q3 are not marked. So we'll be not marking Q0 and Q1. So in the same way, we'll be checking for all the unmarked states in the table. So if we consider Q0 and Q3, here on giving A it both enters into the Q1 itself, and on giving B it enters to the Q2, Q4. Here in the table Q2, Q4 is marked. So we'll be also marking Q2, Q3. So in the same way we'll check for the all the states and we'll be marking. So in the final Q0, Q2 will be left over as unmarked states. So this will be the solution, and we'll be drawing the minimization of DFA based on this. So the final DFA is as follows. Q0, Q2 will be the starting state and Q4 is the final state. Q0, Q2 on giving A it goes to the Q1, on giving B it remains in the Q0 and Q2 itself as it is a self loop. Q1 on giving A it is a self loop, it remains in the Q1 itself. On giving B it goes to the Q3, and Q3 on giving A it goes to this Q1, on giving B it goes to the Q4, and the final state Q4 on giving A it goes to the Q1, and on giving B it goes to the Q0 and Q2. So this will be the minimization of the DFA, the final DFA. Thank you guys for watching.